Hey, this is PreCalc 3.5 Day 2. Today what we're going to be looking at is solving logarithmic equations, and we're looking at method A, condense to a single log, isolate the log piece, and then convert to exponential form to exponentiate the both sides, and then we're going to solve and check. In method B, we're going to get one log on each side, use the one-to-one properties, and solve and check. Now the difference on the one-to-one idea is kind of like raising it as an exponent, okay, except we just kind of don't pay attention to that. So I'm going to give you an example of what that means. So method A means condense to a single log, isolate the log piece. So I've got to condense to a single log, and I'm going to isolate the log, and then I'm going to convert to exponential form. So I'm going to exponential form it. Okay, so I've got 3 to the 4th power equals x plus 2. This is 81, subtract 2, so I find out that x is 78, or 79, excuse me. Now, keep in mind as I'm looking this over, the difference between the exponential form and exponentiate both sides is I'm going to take and raise both sides to be exponents with a base of 3. So I've got that going on. And this property, there's a property in logs that allows me to say, hey, well, this is x plus 2 equal 81. So it seems like it's the same, but it's just a very subtle difference. And that's the difference between the exponential form and the exponentiated forms. Now, if I'm still working through method A, I'm going to, do the exponentiation version of this. And so I've got my base, which is 10. I got a base 10. 10 to the 2nd power is equal to x squared. So I'm going to solve it this way. And I'm going to find, well, I've got this going on. Right now it looks like x is 10 because these are the same. But I've got to be careful about that when I square it and then I take the square root. I find out that x could be plus or minus 10 because of version and negative version. If I do the log version of this, if I take the log of both sides, I've got the log of x squared, and I drop it in front, so I take my 2 and drop it in front, and I've got 2 log of x equal 2. Okay, didn't do anything special, but now I'm going to divide by 2 and find that the log of x equals 1. Well, that means that x must be 10 if I take and think about, well, if I raise them both to the 10, so it's a one-to-one correspondence, and x is 10. Well, there's a difference in these two answers, and the difference is, I'm missing x equal negative 10 over here. If I look at the graph itself, and in looking at the graph, I'm able to see that my graph goes this, and this is where my 10 is, but this is my negative 10. So I've got to make sure that I'm careful as I'm dividing things out and using my log properties that I plug it back in and then reason it out. Well, if I put negative 10 in for x, will this be a possibility as well? And I also want to look at my graph. I'm allowed to have my calculator on some parts of the test just to make sure that I'm fulfilling both sides of my result. And all I did was y1 was log of x squared and y2 was equal to find those answers. Now am I moving on? If it allows me to move on, I'm looking at my extended solving. Now I'm going to solve logarithmic equations, logarithmic equations algebraically as I'm looking at this. So I'm going to subtract 4 from both sides, and I get 3 log to the base 3 of 2x equals 16. So I subtracted 4. Now I'm going to divide by 3 because I got the 3 there because I'm isolating my log. So I've got my log isolated, and I'm going to raise them both to the 3rd power, and that's 2x is equal to 3 to the 4th power. That's what I get to do. Okay, and I could look at it as 3 to the 4th power equals 2x. And then I take 3 to the 4th, and that's 81. So 81 divided by 2 is going to give me 81 halves, or 40.5. That's my final answer. And I can plug it back in just to double check to make sure it's going to work, and it does. And the really big thing about checking if it works, is it positive? Is it a positive argument inside? Okay. So just check to see if it's positive. It's 81, it's 4 times 3 is 12, plus 4 is 16, so it'll totally work as I evaluate. Here, I'm going to look at this and I'm going to kind of condense it down. Remember, when I add logs, it's the same as having them inside a log that's multiplied. So that's why I multiply them. I'm going to distribute or do FOIL on x plus 2 and x minus 1. So I have x squared plus 2x minus x minus 2, and I get x squared plus x minus 2. Now remember, I kind of did two steps there. I multiplied them together, raised it, had these be powers, or I look at it as do the exponent version. So this raised to the first power is equal to 10, or 10, excuse me, raised to the first power is equal to this. I'm going to add 10 or subtract 10 on both sides, get everything on the same side. So I've got this situation, x squared plus x minus 12. Well, I should be able to factor this as negative 4 and 3 or negative 3 and 4. If I look at it, the bigger one's got to be positive, so I'm able to find that it's x minus 3 and x plus 4. Now, I evaluate these, and I think about it and go, okay, x is 3 or x is 4, and I get negative 4, and I should check the answer. When I plug 3 in, I get 5, and I get 2. Both of them are positive arguments inside a log, so it will work out as a solution. But if I look at this one, x equal negative 4, this is a negative and so is this. And I can't take the log of a negative value. So I'm checking my answer, and negative 4 is an extraneous answer. So I've got to make sure I'm aware about what my answers are doing, what they're saying as I go through my problems. In E, I'm looking this over. This is 2, this goes up to the top, so this is log base 4 of x minus 5 squared. And that minus of log base 4 x minus 5 to the cubed. And this is on the bottom, x minus 5 cubed, x minus 5 squared is on top. So this relationship rewrites as this, if I condense it down to 1 log. Now I got 4 to the first power is equal to this, but I can reduce these. And I know that 1 over x minus 5 is equal to 4. That's what I've got. Okay, take a little moment. Remember, we were able to condense it, and then we reduced inside, and we're here. Now I've multiplied by x minus 5 on both sides, and I get this 4 times x minus 5. So I got 1 equals 4x minus 20, and I solve for x by adding 20, and I get 21 is equal to 4x, and I divide by 4, I got 5 and 1/4 equals x. When I plop that back in, just make sure that's going to be positive there. That'll be positive there. So I'm very happy with my solutions, that it's going to be a positive solution in both situations when working inside with my logs. Now the method B, where I condense it down, I use that stuff and condense them down. I've got 3x minus 2 and x minus 1. Those are going to condense down, and I'm going to multiply them out. This is a natural log. So I raise it to the e power, and I'm going to FOIL these. So it's going to be 3x squared minus 2x minus 3x plus 2. Minus 2x minus 3x is negative 5x. So it's 3x squared minus 5x minus plus 2 is equal to x squared. I can get this x squared over here. I'm going to subtract off 1x squared, and I'm at this situation. Now I'm going to FOIL this. Okay, and remember, I was able to do this because I took these. This is a 1-to-1 thing. This and this are equal, so these have got to be the same. I'm going to FOIL this, and I've got 2x minus 1 times x plus 2, or minus 2, excuse me, because it's a negative. So I'm here, and now I'm going to use zero product rule, just like I've always have. And I'm going to set 2x minus 1 equals 0, and I find that x is a half. And I've got x minus 2 is 0, so x is 2. Well, I use that, and I plop them back in. Positive 2 times 3 is positive 6 minus 2. That's a positive answer inside, so it's that'll work. 2 minus 1, positive answer inside. If I used 1/2, 3 times a half is 1.5. 1.5 minus 2 is a negative value inside here. Well, if that's negative, I can't take the natural log of a negative value. So checking my solution, I find out that that 1/2 is erroneous. It's an extraneous solution. not erroneous, but extraneous. It's an extraneous solution, so as I'm looking through this, I don't have it come across it 1/2, I have it come across it 2. So although it was a really great idea, I'm just knocking out the one that doesn't work. So make sure you're careful about that and you compare your solution as you're, as you plug them in and make sure it can work out. Now, solving the logarithmic equation algebraically still, I'm looking at this. I'm going base 2. Everything's the same base, which is great. But this is x times 3x squared. So this is log base 2 of 3x to the third power, okay, times log base 2 of 24. So I've got 3x to the third power and 24. Remember, I'm raising both to the second power, and I've got 3x cubed equal 24. Okay, that's since I can look at this, is 3x cubed and 24 must be the same. And now I just solve. Divide by 3, I get x cubed is 8, and I take the cubic root, and x is 2. I plop it back in, that's 2, it's 1. That's 2 squared, which is 4, times 3 is 12, so that'll work out, no problem. And my last one, I'm going to use a change of base formula here. I've got this as 100, and this is 10. So I'm going to use base 10 on my change of base. So I'm going to have log, natural log, of x squared over natural log of 100 minus log of x cubed equals 6. Okay, and that's where I'm at. This becomes 2 because log base 10 of the 100, remember, 10 to the second power, so it returns the power that 10 would be held to. Okay, so that's 2 right here as I look at that over. And this in front drops in front here. So this goes in front because that's raised to the second power is here. So now my 2's cancel out. They become 1. I shouldn't say they cancel out. They become 1. And so that goes like that. And so now I've got log base natural log of x, not natural log, common log of x, minus common log of x cubed. Well, that's the same as the common log of x divided by x cubed. If I condense that problem. Now I've got 10 to the 6th power is equal to 1 over x squared. Okay, as I'm looking this over, 10 to the 6th power is 1 over x squared. But it's the same as 10 to the 6th power is equal x to the negative 2 power. So 10 to the 6th and x minus 2 power. And now I'm going to get this solved for just x. So I'm going to multiply or take the negative half root of both sides, and that's what I'm doing to make this 1. I chose to make this 1 so I can find x. So I chose a value that would make that negative 2 a positive 1. So that's why I chose negative 1/2, because that makes a positive 1. And because I did it on this side, I'm going to do it on this side. So that gives me this value, x is equal to plus or minus. And why the plus or minus? Because it's an even value. It goes to odds, so it's got to be plus. I've got to consider that plus or minus version. Okay, now what happens if I have a negative version in there? 10 to the negative 3rd power is 1/1000th, but a negative 1/1000th would not be evaluated inside my logs, so I can't have a negative value. So not negative. So I'm dropping the negative, so my value of x is equal to be 10 to the negative 3rd power, which is equal to 1/1000th. So that's my answer using that change of base formula. That's what we're doing today. That's all I've got for you. We've got a quiz going on, so hopefully you did well, but keep working through, ask questions if you've got them. But remember, we have a calculator and no calculator portions of the test, versions of the test as you prep for these. So the gray ones, make sure you're able to do without the use of a calculator. And let's review today's assignment. That's the stuff for tomorrow. And here's today's assignment. 3-5 day 2, page 301, numbers 7 through 10, 17 through 18, 25 to 28, and 35 to 38. Okay, have a great day, folks.